Welcome back guys to all of you. Yes, welcome back guys to all of you on this wonderful platform Gradeup. Yes. Okay. Thanks Deepak for your wonderful words. Anjil, hi. Kamran, good evening dear. So guys, today we are going to discuss a wonderful topic. The name is bearings. And guys, I would like to tell you one thing, that bearing is a very important topic. 2 marks are going to be sure for today's class from this session. So technical home tutorial, hello dear. Somnitha, good evening. So guys, this session is going to give you at least 2 marks. So in next 90 minutes, you are going to get an advantage of 2 marks for sure, that I can guarantee you guys, because from bearing 2 marks question is sure, it will come for sure. Good evening Ravi, Rohan. No dear, today's session does not require any previous session concept. This is a fresh topic and independent of all the topics. Let us start it guys. First of all, we are going to have a discussion over the bearing. So guys, when I say bearing, generally students have one thing in their mind. They feel I am talking about the bearing which are going to be used in shaft. And guys, no doubt you are correct. Good evening Ravi, Vikas Yadav, good evening. So guys, generally students have one thing in their mind, that yes, bearing sir is going to talk about the shaft wali bearing. This is correct that we are going to talk about that bearing guys. But I would like to say one more thing at the same time, that guys, bearing is a very generalized word. Akhilesh, good evening. Bearing means anything which is going to bear. Like guys, we all are bearing to each other. Earth is bearing for us. Why? Because everybody of us is bearing each other. Like we all guys have some of the bad habits which our nearby persons, neighbors, friends, relatives do not like it. But guys, still they are bearing us. And we are also bearing them. And earth is bearing all of us. So guys, anything which is bearing something else is known as bearing. So in general, thanks Akhilesh, Bhavan Shankara, good evening, Naveen J, good evening. So guys, I would like to say one thing, that one we are talking about bearing. Bearing is anything which bears. Okay guys, I would like to say guys, it is a very big field, and the name of the field which is dealing with the bearing is known as tribology. And guys, this is a very important term. Yes, we will be discussing about this also later on. So guys, let us say when we are talking about bearing, so bearing is anything which is going to bear. Why I said that, if we are talking about two bodies, this is earth, this is block. And guys, if you are saying that this block is moving like this, so this earth is body number 1, this block is body number 2. And you know there is a relative motion between body 1 and body 2. And at the same time, body 1 is supporting the body 2. So body 1 is bearing for body 2. So if you want to say and want to define a generalized bearing, as I said, the study of bearing is said to be tribology. So when we are talking about this study, guys, bearing is defined as in this way. Like whenever we are having two bodies, out of which one is at rest, other is moving. So whenever we are having the relative motion between two bodies, out of which one is at rest, other is moving, then my dear, the rest body is going to support the moving body. Then the body which is at rest is going to be bearing for the moving body. This is a very generalized definition when we are talking about the bearing. So this is the generalized definition of the bearing. Okay guys, so this is generalized definition of bearing. And when it comes to the bearing with respect to shaft, then guys, obviously this is the bearing which is a fixed member, and there is a shaft which is the moving member. There is a shaft which is the moving member. There is a shaft which is the moving member, and the shaft is moving, bearing is fixed, and bearing is going to support this fix. Bearing is going to support this moving shaft. So bearing is fixed, shaft is moving, and bearing is supporting this shaft. And guys, at the same time, bearing is confining the motion of the shaft. That the motion of shaft can be only in between the bearing. It will not allow the shaft to move in the direction of applied load. That is something known as bearing with respect to shaft. So guys, bearing is defined as in general also. Bearing is defined with respect to shaft also. I hope you guys are getting it. So in general, bearing is something which bears, and bearing with respect to shaft is nothing but guys, it is a fixed element which supports a moving element in such a way that it confines its motion as well as support it, and in such a way that it also resists, it also restricts the motion of the shaft in the direction of applied load. That is the wonderful definition guys for bearing with respect to shaft. Yes guys, now I will be showing you a very small discussion about the classification of bearing. When we are talking about the bearing classification, guys, bearings are of two types. Number one is sliding contact bearing. Number two is rolling contact bearing. Guys, if some sliding surface is going to bear the load, it is said to be sliding contact bearing. And if some ball or some rolling element like ball is going to bear the load, then it is said to be rolling contact bearing. When we are talking about the sliding contact bearing, guys, it is of two types. One is sleeve bearing, other is slipper or guide bearing. When it comes to slipper or guide bearing, that we have seen in the theory of machines. If you are talking about the slipper or guide bearing, dear, this is a cylinder, this is piston, and you know this is cross head. And guys, this cross head is moving between this guide or slipper or guide bearing. So guys, these are slipper or guide bearing between which the slider is going to move like this. Now this is crank of radius R, this is connecting rod of length L, and guys at the same time this is the slider. And guys, you know that this is known as slipper or guide bearing. So guys, this type of bearing are not in our syllabus. We need not to discuss that. That's why I have shown you for once. So we are not going to discuss this type of bearing because they are not of our syllabus. In our syllabus, we need to discuss about the sleeve bearing, guys. Ravi Swan, hello dear. RM10 Gaming, hi Ravi. Okay, you got it, fine, wonderful guys. So now we are talking about the sleeve bearing. Guys, sleeve bearing are classified with respect to load, with respect to lubrication, with respect to configuration. When we are talking about with respect to load, guys, number one is radial load bearing, other is axial load bearing. What do you mean by radial or axial? Like, let us say if you are having a shaft like this, and when you are having a shaft like this, I am showing you the cross section of the shaft also. So cross section of the shaft is this. So if you are going to bear the load which are acting in this direction, they are known as axial load. And that bearing which is going to bear this load is known as axial load bearing. And if the load is acting in this direction, so the bearing which are going to bear this kind of load are known as radial load bearing. So guys, when we are talking about radial load bearing, it comes under full journal bearing, fitted journal bearing, partial journal bearing. That we are going to see in detail after some time. And axial load bearing is having pivot and collar. And guys, whatever you will study here, it is going to help you in clutches also. So to study clutch or to study this topic is same. Okay, so mind one thing guys. Okay, Sarath sir, it is my request you take series in theory of machine. Dear, theory of machine series is already been completed. Only one topic is pending there. So what do you want to ask about this? Already the theory of machine was the subject from which the series started in the November month. So that is already been completed. Only one topic is left, that is cams and governor. Okay, all other things are already been completed. You can see the already completed session. They are available on the YouTube. So guys, now the next is with respect to lubrication. So guys, there is one known as thin film lubrication. This thin film lubrication is like you are having the layer of grease. That is known as thin layer lubrication, thin film lubrication. It is also known as semi, you can say semi thick or that kind of lubrication. Next is thick film lubrication. If you are going to use liquid lubrication, then for liquid lubrication you are going to say it is the hydrostatic and hydrodynamic. It is hydrostatic and hydrodynamic. We are going to discuss that also in detail. When you do not provide any lubrication, it is known as zero film or solid lubrication. So guys, these are the types of lubrication we will be dealing with. You know, lubrications are provided to reduce the friction. Atul Kumar Pandey, okay, fine. Nice guys. And guys, next is the based on configuration. When we are talking about the configuration, I would like to say guys, there is one bearing which is known as solid bush type, which is present in the single piece. There is another one which is present in the multi-piece, two pieces, that is known as a kind of split bush type. So dear, if bearing is present in single piece, it is solid bush type. If it is going to be in double piece, it is going to be split bush type. It is going to be split bush type. Hope you got it guys. One is solid bush type, other is split bush type. So guys, these are the two types based upon the configuration. Then guys, we will be talking about rolling contact bearing. One is ball bearing, other is rolling roller bearing. So one is deep groove ball bearing, other is self-aligned bearing, then the needle bearing and taper roller bearing. Out of this in our syllabus, we need to deal only with this. Then cylindrical roller bearing, spherical roller bearing, needle, basically needle bearing is not coming in this. This is taper roller bearing only. Okay. So these are the things we are going to discuss. Basically the thrust bearing will be coming in front of that. Okay, hope you guys are getting. But this classification is not important much. You need to discuss about these bearings plus these bearings and this bearing. No other bearing is required. 2 marks question will be coming either from this or from this. And guys, this topic is going to be covered. Basically, that is known as the weightage is going to be in clutches. Because the theories you will be dealing here, you will study in the clutches. So now we are going to move further. We have already seen that. That is another example of slipper or guide bearing. This is coach yoke mechanism. So this is again slipper or guide bearing. Okay. Yes guys, let us move further. We have already seen what is sleeve bearing. Now we are going to discuss in detail the axial load bearing. You have already seen if the loading coming is axial in nature. Good evening AK Kushwaha. Okay, fine guys. So now guys, let us start a discussion about axial load bearing. When we are talking about the axial load bearing guys, when we are talking about the axial load bearing, it is of two types. One is pivot bearing, other is collar bearing. So guys, one is pivot bearing, other is collar bearing. So when we are talking about the pivot or collar bearing, guys, obviously in both the cases loads are acting in the axial direction only. Like this is pivot bearing when we are talking about, this is flat pivot, this is conical pivot. If you see the flat pivot, this is the shaft, this is the bearing surface. So guys, obviously you know the load will be coming in axial direction. This is the axial direction. This is the axial direction. This is the load is coming in axial direction, and this is the friction surface. This is the friction surface. So guys, whenever it will be rotating, obviously this surface will be providing some friction. This surface will be providing some friction. So guys, in this type of flat pivot bearing, obviously the shaft will be rotating like this with omega, and this friction surface will be providing the friction. And this axial load is beared by this bearing. And if we are providing this to be in terms of this cone, it is said to be conical pivot bearing. And guys, when we are talking about collar bearing, what is collar? There is a shaft. On this shaft there is a plate welded like this, and this plate which is welded on the shaft is known as collar. And guys, this collar is acting like a part of this shaft because it is welded onto that. So when you are going to apply the axial force on this like this, so guys, at that time this load will be beared by the collar. How it will be beared? Because if this is the bearing surface, this is the collar. What is going on basically? When you will be applying the force onto this, obviously by this load will be transferred from collar to the bearing. So bearing will not allow the collar to move. If you want to see this view for this case, so this view will make you clear that this is the shaft. This is the shaft. Let us say W is acting. And at the same time, we need not to discuss about W because here we are talking about axial loading. So guys, this is basically a shaft, you know, and this shaft will be having a collar surface. So I am making the collar surface like this. So this is the collar on the cross section of shaft, and I am making it hatched. So this is nothing but the collar. Okay guys, and when we are talking about the bearing, then bearing is having one outer surface, one inner surface. The outer surface of bearing is like this, and inner surface will be just about the shaft, like this. So this is the complete bearing which is fixed. Now guys, if this bearing is fixed, what will happen? Now you can see. Now this is the region. This is the region of contact between collar and the bearing surface. How it is going on, you can feel it now. When this region, this bearing is a hollow. This bearing is a hollow thing. Okay guys? This bearing is a hollow thing. And this collar, whenever you are applying the force onto this collar will be applying the force onto this surface. And obviously you can see collar is also cylindrical in nature. But yes, bearing surface is quite bigger than that of the collar surface. So this is how the cross-sectional view looks like, and this is only the part which is going to bear all the kind of loads. And you know that this is the axis, longitudinal axis. This is how the load is going on, and this load is beared by this surface with the help of collar. So this red one is nothing but collar, and this is nothing but bearing. Bearing is something hollow circular. Collar is something solid circular. Sorry, shaft plus collar is solid circular. Okay guys, fine. Guys, please tell me, are you getting the things or not? Because whenever I will be teaching you axial load bearing, clutches will be completed for the gate automatically. I will say for the gate because for gate questions are coming only from uniform pressure theory or from uniform wear theory. But when we are talking about the other examination, their questions are coming from centrifugal clutches as well. So there the things will be different somehow. Okay guys, so let us move further guys. So now when we are talking about the collar bearing, if the collar is flat, it is flat collar bearing. If the collar is inclined like this, it is known as conical collar bearing. Deepak, okay fine, good. So guys, these are the types of bearing we are going to discuss. Let us move further guys. Let us move further. So when we are talking about the next part, design of collar bearing. As I said, this is the shaft and we are applying W in the axial direction. You can see this Ri is the radius of shaft. R naught is the radius of collar. Obviously the contact will be starting from this surface, from Ri, and contact will be there up to R naught. So this is the contact surface between the collar and the bearing. This is the contact surface between the collar and the bearing. Okay guys, and you know one thing, whenever you are applying this W, this will be beared by the contact of collar and the bearing. So guys, this W is beared by this surface area. So guys, whenever we are applying the force like this, obviously there will be some pressure induced onto the friction lining because of this load W. But at the same time guys, as you know, this shaft is rotating also. So obviously there will be a relative motion between this collar and the bearing surface. Because one thing is fixed, other thing is rotating like this. So there will be when it will be rotating like this. Obviously this is the surface of bearing which is fixed. Shaft is moving like this. It is like this. If I am showing you on some newspaper like this, this is the surface of bearing which is fixed. Whereas shaft is rotating like this. So there will be a relative motion between these two always. Okay. So this relative motion, because of this, Ravi, I didn't get how inner circle form. Dear, because this is shaft, this is collar, and this is bearing. So if this is bearing will be having some inner and outer circle. No? Okay, this is the case. Shaft, collar is welded on this, and let us say this is bearing. So when the load is coming, it will be acting like this. So bearing is having some inner circle, some outer circle. Bearing is also like this, but bigger than that of the collar. But bearing is hollow, whereas collar is welded over the shaft. Hope you are getting it now. Okay, collar is welded over the shaft. Yes guys. So when we are talking about this now, so this W load is beared by this surface. But as you know, this shaft is not stationary. So shaft and collar are going to rotate like this. So when they will be rotating, there will be a relative motion between shaft, collar, whatever shaft or collar, and the bearing surface. So because of that bearing surface is fixed, shaft and collar are moving, there will be a relative motion which will cause some friction. And guys, this friction will be present between the surface. And when this friction will be coming, obviously it will try to stop the motion and there will be some frictional losses and we need to find out that frictional losses. Dear प्रतीक, कोलर ही तो है जो कि आपका लोड ट्रांसमिट कर रहा है बियरिंग को. कोलर अगर नहीं होगा तो शाफ्ट तो बियरिंग में से निकल जाएगा ना. Pratik, if collar is not there, shaft will pass from the bearing, like this. So it is the collar due to which the bearing is able to withstand that load, because collar will not allow the shaft to pass from the bearing. Hope you got it now. Pratik. Yes or no, Pratik? Yes, Pratik. Is it fine? Okay, guys. So let us move further now. So dear, now we got one thing, that W load is beared by that surface, and I have just shown you that surface. I am showing you again. This is the bearing surface. This is the bearing surface, guys. If this is the bearing surface, you know one thing, this is the shaft and at the same time this is the collar. Collar is welded over the shaft. And if you see the bearing inner surface is just near to the shaft. So you know one thing, that this is Ri, this is R naught. So contact is between Ri to R naught. Contact is between Ri to R naught. Okay. So if the contact is between Ri to R naught, obviously guys, now we are going to discuss about the design. So guys, I am just taking add some small r radius. I am just taking add some small r radius, a very thin ring. I am taking a very thin ring, and this thin ring is having the thickness of dr. This thin ring is having the thickness of dr. So guys, this is having the thickness of dr. Yes, Pratik? Okay, fine. Okay, no issue. Okay, no issue, Pratik. Very good. So guys, now we are going to see, this is the small thin ring which is going, let us say this is a very small thin ring, and we want to find out the area of this small ring. So let us say dr is the thickness, r is the radius. So the small area of that ring is going to be 2 pi r dr. So this is the area. And you know, if you want to find out the chota sa load, the small load, differential load beared by this ring will be pressure into this small area. Pressure into this small area. So guys, now if that is the case, if you want to find out the total load, you need to integrate it. So when you will be integrating, delta W will become W, and this P will become, this is P into 2 pi r dr. So guys, now if we are talking about, we are having two theories here. One theory is UPT, which says pressure to be constant. Other theory is UWT, which says pressure into radius ka product is going to be constant. So guys, if pressure is going to be constant, then when you will be solving it, obviously pressure at 2 pi will be coming outside, and you will be getting W to be equals to 2 pi P coming outside. Integration will be there from inner radius to outer radius, because exactly the product started from here and here. So you will be having integration of r dr from Ri to R naught. It is equals to 2 pi P. And you know that it is going to be r square by 2. So it will be r naught square minus Ri square by 2. So 2 and 2 will be getting cancelled out, guys. And you will be having this pressure induced to be equals to W divided by pi r naught square minus Ri square. You might be thinking, sir, it was very easy to find out. Why you have done in such a complicated way? You have simply done the load but area. But guys, this is coming like this because pressure is assumed to be constant. Once you will be using UWT, then this result you will not be getting, then the results you will be getting will be different. So guys, at that time when you will be having For UWT, the W will be coming out to be equals to, it will be coming out to be equals to, it will be, okay, I am writing the P induced. Then P induced will be coming out to be equals to W divided by 2 pi small r naught minus Ri. Then this will be the value using UWT. So by UWT, this will be the pressure coming. Dear, this P induced is a constant value. So here pressure is a constant. But you know here pressure is a variable. Because here this small r is variable. And you know this small r can vary from Ri to R naught. So when this small r will be minimum, pressure will be maximum. When this small r will be maximum, pressure will be minimum. So guys, you can write that if you want to find out the maximum pressure, you will be getting W divided by 2 pi Ri into R naught minus Ri. And you will be having P minimum as W divided by 2 pi R naught into R naught minus Ri. So this is the way we will be getting the minimum and maximum pressure values. We will be getting the minimum and maximum pressure values. Okay guys, this is how you can find out the minimum and maximum pressure values. Hope you are getting it and you are getting these values guys. So these are the values we are getting it. So guys, this is how P maximum, P minimum you will be getting, because in UWT pressure is a variable. Now guys, you know one thing, that if you know the load is W, you know the friction force is always mu times the normal load or axial load. So mu times W will be the friction force. If you want to write on friction torque, this is the chota sa, very small friction force. Then it will be mu into delta W. Then it will be mu into P into smaller area, differential area. Similarly, the small frictional torque is given as mu delta W into R, and it is given as mu P R into delta I. This is how you can find out the frictional torque. Again guys, we will be having two theories. One is UPT, other is UWT. So when you will be using UPT and UWT, you will be getting the results, and I am directly writing the result. Sir, how did you calculate it P maximum and P minimum? Dear, if you see the expressions for pressure by UWT, you are getting W by 2 pi R naught minus Ri, when you will be using UWT. I have not derived it, I have simply written the expression, because if we will be deriving all the derivation, it is going to be wastage of time for you guys. Okay, so one derivation I have done for you. Second, I am assuming that you will be understanding that, because you need values only, you need not to derive the things. Okay, so this is the expression you will be getting. P is W 2 pi R naught minus Ri. You know pressure is changing from Ri to R naught. So dear, if you will be putting minimum value of Ri, you will be getting maximum value of pressure. When you will be putting maximum value of R, you will be getting the minimum value of pressure. So this is how you can find out minimum and maximum pressure. So Bhagwan Shankara, are you getting it or not? Dear, UPT means uniform pressure theory. UWT means okay dear, just wait. Now screen came or not? Now screen came or not? Please tell me that. Guys, now screen came or not? Okay. Yes, dear Arul, I am coming on to that. Satyam, we are coming on to that point, don't worry. Fine, guys. Okay, nice. So, guys, as I said already, that when we are discussing these kind of things, a very good question is coming, sir. If nothing is mentioned, which theory should be used? So, guys, I will be discussing it later on, but right now I am telling, if you want a hint for bearing, you will be going with UPT, and for clutches, you will be going with UWT. Okay, that is the case if you need to decide it. Okay, fine, guys. So, dear, these are the results, and when we are talking about the UPT and UWT, after integration, you will be getting the result for frictional torque also. And for frictional torque, what the value you will be getting, I am showing you that. If you are going for UPT, you will be getting the frictional torque to be, it will be 2 by 3 mu W. It is R naught cube minus Ri cube divided by R naught square minus Ri square. And similarly, if you see the frictional torque by UWT, you will be getting 1 by 2 mu W R naught plus Ri. So guys, these are the two relations of frictional torque. This is UPT, this is UWT. But guys, and obviously you need to remember both of these two formulas. Hitesh, I would like to say one thing, that definitely we are going to study in Halla Bol series, but they will be taught at the end of the session, because after some other more weighted subjects are coming, like production and all. So MD will be coming in the later section. Pushkaraj, okay, fine. Let us move further, guys. Now I want to tell you one more thing. If you are talking about this is UPT, this is UWT, you have seen the relation for W also, we have seen for T, frictional torque also. Now the point is, what are the real relations? What are the actual relations? So guys, when we are talking about the real or actual relations, if you see the actual loss, this is the frictional torque which is the loss. If you want to see the actual one, it is going to be more than what we are going to get by UWT. It is going to be less than when we are going to talk about UPT. So mind this thing, whenever you are going to find out this, the actual frictional torque loss is coming in between these two values. So it is coming in between these two values. It is going to be more than the UWT and less than the UPT. Okay, this is the thing I wanted to give you guys. So guys, the actual frictional torque is going to be more than UWT and going to be lesser than the UPT. So guys, obviously, whenever you are going for design, you always think of the safe design. Like whenever you give some examination, if you want 40 marks as the passing marks, whenever you just count your marks by your marking, what you try to do? You try to cut your maximum marks so that your marking should be more strict. If you are going to pass in your marking, you will automatically be passed in the examiner's marking. Like you have seen many times, you say this, that the question was of 20 marks. I have attempted for 15 marks. I will definitely be getting a minimum of 5 marks. Why you are saying I will be getting minimum of 5 marks? Because you have faith that lesser than this, nobody can give the marks into that. So if you are going to take the least one, if you are getting passing marks, then nobody can fail you. This is known as the safe design. So guys, in the same manner, I would like to say, guys, if the maximum loss is coming by UPT and UWT is giving you the least one, so I will always be considering UPT for the bearing. Because if I will be considering the maximum loss, my design will be going to be always safer. Okay, like whenever you go for some business, you try to have a condition where at the maximum what can I lose. So by considering that only you are going to start the business. Because if that maximum what you can use, you don't have any issue with that, you can start that business. That is something, guys, related to this concept. So guys, for bearing, always go for UPT if nothing is mentioned. Okay, now it comes to what about clutches? Dear, in clutches, when we are talking about, the things are opposite. Why they are opposite, I am telling you. When we are talking about clutches, in clutches there is a driver shaft. and there is a driver shaft, this is the plate. There is a driven shaft, there is the plate. And guys, if you are talking about this is the axis, and in between some frictional surfaces are there. In between some frictional surfaces are there. In between frictional surfaces are there. So with the help of friction, this driver shaft is rotating because of engine, and guys, the power is getting transferred with the help of this friction. Why? Because whenever they are coming in contact, driven shaft is at rest, driver is moving like this. So whenever they are coming in contact, both are starting moving with the same velocity after some distance. So here friction is not a loss. Here friction is transferring the power. In the case of bearing, friction was a loss. Here the friction is something which is transmitting the power. Okay. So guys, in the bearing, friction was loss. We want to minimize the losses. Okay, in real condition. But for safe design, we have considered maximum loss. So we went for UPT. But when it comes to clutches, guys, in clutches, friction is not a loss. Friction is something which is helping in transmitting the power. So when if it is helping in transmitting the power from driver to driven, here we will be assuming, let us say, what should be the minimum friction in which we can transmit the power. If we can transmit the power in the minimum friction, we will obviously be transferring in more friction. Like if you can survive in 3,000 rupees and you are getting 5,000, it is well and good, no? It is good. So guys, that's why if for clutches, if nothing is mentioned, you will go by UWT. But guys, for clutches, if something is mentioned, like pressure is uniform, you will go by UPT. They are saying uniform pressure, you will go by UPT. You will go by UWT only in the cases when they are not mentioning anything, or they are saying clutch is old. So mind it, for bearing, always go for UPT if nothing is mentioned. For clutches, go with UPT if pressure is given as uniform. In clutches, go with UWT if they are saying that maximum value of pressure is this, minimum value of pressure is this, or they are saying clutch is old, or they are saying worn out clutch. So guys, these are the points you must remember, and this is the discussion over the first type of bearing. Guys, I am teaching you with respect to gate only. Otherwise, this chapter I teach in classes for 2 to 2.5 hours. But here I have given you what is asked in gate. I can guarantee you one thing, that for gate, you will not be getting anything out of these classes. Okay? So if you are okay with the concept, with the formula, I can directly jump to the question on this topic. Then I will move on to the second type of bearing, which are radial load bearing. Okay? So from this, the question are coming in clutches. So in this topic, we have completed the clutches indirectly, because this kind of bearing are not in your syllabus. But for clutches, we need to discuss these kind of theories. Let us see the question over this topic. And guys, I will be showing you some questions. They are from gate. So you can have a proof like this. These are the questions which are required for gate for sure. So dear, this is the first question you will be solving for gate. A clutch has inner and outer diameter. They are giving inner diameter to be 40 mm, outer diameter to be 100 mm. A uniform pressure of 2 MPa. They have said pressure to be uniform. Pressure to be uniform means pressure to be constant. So you will be using UPT now. So you will be using UPT because pressure is given to be constant. And guys, coefficient of friction is given to be 0.4. Find out the torque carrying capacity of the clutch in Newton meter. Very good, Pratik. Ravi Kumar, I just said that there was one shaft which was driven, there was another shaft which was driven. So I have made the diagram like this. This was driver, second was this driven. now UPT says TF will be 2 by 3 mu W R naught square minus Ri square, sorry, Q. W is okay guys, so let's solve this question. Solve this question guys. Yes, very good guys. The answer will be coming out to be equals to TF is 196 Newton meter. This will be the answer. Yes. Okay guys, let us move further. Let us move further. This is the next question guys. A disc clutch is required to transmit a power of. Power is given to be 5 kilowatts. You can write it into TF into omega. And from that you can find out the frictional torque. And you know it is already mentioned the inner radius is 25 mm. Inner radius is given as 25 mm. And you need to find out the outer radius. Pressure is again given to be uniform. Yes guys, so you need to find out the outer radius for this, and using the UPT you know again 2 by 3 mu W R naught cube minus Ri cube R naught square minus Ri square, and W is P pi R naught square minus Ri square. You need to find out the value of R naught. Okay guys, anybody else? What will be the answer guys for this question? Yes. So are you getting around 55 mm? Are you getting about 55 mm? Guys, I feel you have done some calculation mistakes because this n is given and this power is given and this is inner radius. So when you will be finding out the outer radius, the answer will be coming out to be 39.4 mm. Please check your calculation mistake. And pressure is also, when you are talking about, is given as 1 MPa. So everything is given. I feel you have done some calculation mistake. From the power, first of all, find out torque. You are given with n. So omega is 2 pi n by 60. So using this, you will be getting TF. From TF, you will be finding out. W is given to you. You will be putting in terms of R naught. R naught. This term will be cancelled out with this. You will be getting R naught to be 39.4 mm. Okay, so some calculation mistake you are doing. Okay, Mukesh, Deepak and Pratik. Yes, 55 will not come. The answer will be coming out to be 39.4 mm, guys. Yes, very good, Akhilesh. No, dear, this is the correct answer, 39.4 mm. You are doing some calculation mistake. Sir, what is the case when bearing having residual stress means? Dear, residual stress means the stresses which are remained even after the removal of loads. Okay, they are residual stresses. Very good, Akhilesh Kardse, Aman Juneja. Now you are getting the correct answer. Let us move further, guys. Let us move further now. Okay. The last question for this topic, guys. Then we are entering to the second type of bearing. This time a disc clutch having a coefficient of friction for the friction surface to be 0.3. Maximum pressure, which can, this time maximum pressure is given. You know maximum pressure is W by 2 pi R. R naught minus Ri. When this R becomes Ri, pressure becomes maximum. And it is given to be 1.5 MPa. The outer radius of the friction lining R naught is 100 mm. Inner radius is 50 mm. Apply uniform wear theory. Find out the frictional torque. UWT you need to apply. Find out the value. Yes, Mukesh. Okay, Pratik, no issue. Some calculation mistakes may be coming because of solve this question. Very good, Abhishek. You got the right answer. The answer for this will be 530 Newton meter. So with this, guys, we have completed one type of bearing. Now we are entering into the second type of bearing. So guys, the second type of bearing when we are talking about is nothing but the radial load bearing or journal bearing. And journal bearing is good for radial loads. So this time you can see this is shaft and the radius of shaft is R. And you can say it is R and the radius of bearing is R1. Okay, and guys, you can see bearing is like this. This is also cylindrical in nature. This is the length of bearing and this is the diameter of bearing. If you see the cross-sectional view, this view, then I will be showing you this view. First of all, I am going to make the bearing surface, guys. So this is the bearing surface. And now I am going to make the shaft surface, which is journal or shaft. This is journal or shaft. And guys, in between, lubricant is there. in between lubricant is there. In between lubricant is there. This is lubricant. This is lubricant. This is, guys, inner shaft, W is the weight. This is the bearing. This is the bearing. Okay, guys. So this is the case. You can see load is radial and this is the lubricant present. And guys, this is the length of bearing. So bearing is also cylindrical element having some length also. Here there is no collar. Here there is no collar. This is not a collar bearing. This is the radial load bearing, journal bearing. And guys, sir, how many hours you teach to student on daily basis? Then it depends why you are interested in that thing. You must take interest in studies right now. Exam is about to come. After exam, you just have a call to me. I will be telling you everything about this. Okay. First, let us see this. So guys, when we are talking about this shaft and bearing, this is the length of bearing, and guys, why it is said to be journal bearing? This is known as journal. So now the students are having a doubt. Okay, sir, shaft is known as journal. So I will say, no, dear, shaft is not journal. Only the part of shaft which is inside the bearing. The part of shaft which is inside the bearing, this is journal. The part of shaft which is inside the bearing is journal. So journal is nothing but the part of shaft which is inside the bearing. So journal is the part of shaft which is inside the bearing. Okay, guys, this is journal. So only that much part is said to be journal. Complete is not said to be journal. Mind this thing. This is very important point for interviews. Now let us move further, guys. Now let us move further. So guys, now we are going to discuss about this. If you see, if you are going to say that journal, if you are going to say journal, you know the journal radius, journal or shaft radius is nothing but R. And if you say about the bearing, then for bearing we are assuming the radius to be R1. So if you are going to define the radial clearance, then radial clearance is nothing but R1 minus R. Okay, and there is some diametral clearance. Diametral clearance is D1 minus D. And you know, if radial clearance are denoted in with C1, it will become C, which is equals to 2C1. So diametral clearance C is 2 times of radial clearance, guys. Okay, this is the case. And guys, hope you guys are getting. You welcome Satyam. Pushkaraj, very good. Very good, Pushkaraj. Let us move further. Sir, in third is equals to S. There is no axial. Dear, this is not an axial load bearing. This is a radial load bearing. I already told you, na? We have completed axial load bearing. This is a radial load bearing. Okay. This type of bearing is having radial load. Previous bearing was having axial load. So now axial load bearing is completed. We are going to discuss the radial load bearing. So don't worry about that. This is the new type of bearing we are going to discuss. So guys, now let us move further. Yes. So guys, now let us move further. So dear, now we are going to discuss about the journal bearing. So we are having a shaft or journal. This is a shaft or journal. And dear, this outside is nothing but the bearing. So you can say journal is inside the bearing. So when journal is inside the bearing, this is the W load acting. And you know, you can see that shaft is inside the bearing. And this is the W load acting in this. And this is rotated with an angular speed of n RPM, revolution per minute. And guys, I have shown the gap to be very big. This much gap is not there. For understanding purpose, we have written like this. But let us say this is the condition at rest. For this condition, we are assuming shaft is not rotating. Shaft is at rest. And this lubricant is provided at 1 atmosphere. So guys, shaft is very, very heavy because of the components like gears, rotors are present over the shaft. So because of that heavy shaft, this lubricant at 1 atmosphere pressure cannot bear this heavy shaft. Okay, so shaft is having a direct contact with the bearing, and you know W is the load and will be the normal reaction. There is no friction and there is no relative motion. So guys, this is the condition where the line of action of W and line of action of N are not different, but they are same only. And for this condition, W will be equals to N. N is the normal reaction, so I am denoting it by NR. So it is equal, both are equal, and you know for equilibrium this is must. So guys, you can say this is the very first type of lubrication, hydrodynamic lubrication. It is a kind of thick film lubrication. Okay, and I would like to say one thing, that when we are talking about the thick film lubrication, this thick film lubrication or hydrodynamic lubrication is the lubrication where at the rest metal to metal contact is always there. At rest condition, metal to metal contact is always there. So guys, whenever the relative motions are coming, then metal to metal contact is not there. But in the starting position, metal to metal contact is always there. It is not avoided. So this is a kind of lubrication where at rest condition, metal to metal contact, you cannot avoid it. This is one thing I would like to tell. Then guys, let us move further. In the second case, when you are going to give the rotation to this shaft, I am showing you what will be going on. Like you know, this is the bearing. This is the bearing which is at rest. This is the bearing which is at rest. Now we are talking about the shaft. Okay, I am showing the shaft onto the same condition which we were talking about. We were having the shaft into this position. This is W. Now let us say shaft is going to start rotating in clockwise direction. Obviously bearing and shaft in between there is lubricant. When shaft is starting rotating with some n RPM, revolution per minute. When it is starting rotating with n RPM, this time friction will be coming into the picture. And there will be some relative motion, and you know there is normal reaction, N and W are acting in the same line, and there will be some friction force will be coming, and this will be the friction force. This is the normal reaction, and guys, this friction force is having a tendency to move this journal or shaft into this direction. So what this friction force will be doing? This friction force will be resulting into the motion of the journal or the shaft. Motion of the journal of the shaft, okay, into this direction, and this journal will be shifted to the new position, and this will be shifting up to the point when this W will be coming equals to the resultant of this normal reaction and mu(n). This will be moving until the distance when the resultant of N and mu(n) will be coming out to be equals to W. Okay, and the motion will stop now for the shaft. Only this type of motion, rotation is going on. Now guys, what happened? Bearing is at rest, shaft is rotating. So there always, whenever this lubricant is there, the lubricant due to no slip condition, it will be making a layer over this shaft. Due to no slip condition, it will be making a very thin layer over this shaft. And this thin layer, with the movement of shaft, will try to enter into this. As the speed will be increasing, this layer thickness will also be increasing, and once the layer thickness is becoming that much, you know, because of this rotation, this fluid is going to be pressurized. Like you take your hand and just give the motion, Okay. Okay. Okay guys, please tell me, are you getting it or not? Abhi, dear, for this topic 2 marks question is coming. So I am giving you this type of thing because this type of thing is going to help you in scoring in all type of examination. So what happened is, this lubricant is making a layer over this shaft, and this will always try to enter into this region from this region. So when this lubricant will be entering, it will be forcing the shaft to move here, and guys, then the metal to metal contact will be leaving, and then the shaft will be, the weight of the shaft will be beared by the lubricant. This is the condition when we are talking about the metal to metal contact will be avoided. The metal to metal contact will be avoided. Okay. So dear, from this topic 2 marks question is coming. From this topic means from the complete bearing chapter. Okay. Yes. So guys, this is something I wanted to tell you, and don't see some of the messages, because these days many of spammer are coming, like you have seen previous also, and this is going on in all the classes at all the platforms. They are just coming and they are writing anything, so don't mind them. Rather than that, we will remove from that chat. Okay, so don't worry about that. Yes, and this guys, whatever we have said, whatever we have seen, this is known as wedging action of shaft. This is known as wedging action of shaft, and there is one more name for this. It is also known as dynamic action. So it is wedging action or dynamic action. And guys, because of this wedging action and dynamic action, at higher speed, the contact between shaft and bearing is going to be avoided. So hydrodynamic lubrication is good at high speed, but it is not good at slow speed. Okay guys, it is good at high speed, but not good at slow speed. So let us see now the hydrostatic lubrication. Guys, now let us see the hydrostatic lubrication. When we are talking about hydrostatic lubrication, what is hydrostatic lubrication? Dear, in hydrostatic lubrication, if this is the bearing, we are providing the lubricant with the help of a pump. We are providing the lubricant with the help of a pump at higher pressure. We are providing the lubricant with the help of a pump at higher pressure. So lubricant is provided at higher pressure, P more than atmospheric pressure. So lubricant is provided at a higher pressure, at a pressure more than that of the atmospheric pressure. And guys, when we are going to talk about this, they are provided at higher pressure, and as they are provided at higher pressure, so pressure is more than atmospheric pressure. Obviously, because it is already having high pressure, so this high pressure lubricant is capable of bearing this load of shaft from the stationary condition only. So the best thing about hydrostatic lubrication, even in the starting condition, you will not be having any metal to metal contact. डियर, गेट के लिए ईएससी कन्वेंशनल क्वेश्चन करना यूजफुल नहीं है हर सब्जेक्ट में, क्योंकि कुछ ईएससी कन्वेंशनल ऐसी चीजें पूछते हैं जिसका गेट से कोई लेना देना नहीं होता. मशीन डिजाइन के लिए कन्वेंशनल आपको बिल्कुल हेल्प नहीं करेंगे. फॉर मशीन डिजाइन यू विल नॉट बी गेटिंग एनी हेल्प फ्रॉम द कन्वेंशनल. ओके, यस डियर, at rest also there is no contact, because lubricant is provided at high pressure. It is already bearing the journal, so there is no need of motion for that. So dear, in hydrostatic lubrication, contact is not there even at static condition. In hydrodynamic lubrication, contact is not there only at higher speeds. So at higher speeds, hydrodynamic lubrication is preferred. At slower speed, hydrostatic lubrication is preferred. If you are going to use a combination of these two, it is said to be mixed lubrication. Guys, these things nobody will teach you in this crash course type of classes. I am giving you because I want to make you foolproof for the exam. Okay, let us move further guys now. So dear, that we have already discussed about hydrostatic, and when we are talking about differences, I already told you everything. Like I told you, if you are providing pressure at higher, if you are providing lubrication at higher pressure, the cost of lubrication will increase. So cost of lubrication is less in hydrodynamic, it is more in hydrostatic. Obviously, fluid is provided higher pressure here, lower pressure, atmosphere pressure here. Metal to metal contact is avoided at high speed, even at stationary condition. Everything out of these we have discussed in detail. So there is no need to go for this table. We have already discussed this in a great detail. Okay guys, so now I am coming on to the topic where the questions are coming. Okay, where the questions are asked, I am coming on to that. So guys, the questions are coming from three conditions, three things. One is the bearing characteristic number, second is the Sommerfeld number, and the third is the expressions for power loss. Only these are the three types of questions which are asked from this chapter. So one by one I am discussing all the types with you, all the three formulas with you. Just try to understand this topic in a careful manner and wonderful manner. So dear, let us say we are having a bearing like this. Let us say we are having a bearing like this. Let us say we are having a bearing like this. And now for this bearing, I am saying that we are going to have a journal bearing with hydrodynamic lubrication. So you can see, obviously this will be the center of journal, this will be the center of bearing. So the gap between these two centers is said to be eccentricity. And you know one thing, that this radius is obviously the radius of shaft. And if you see the distance up to this is the radius of bearing. Okay, I am showing it with the capital R. Okay guys. So this is the minimum film thickness of lubricant. This is denoted as H naught. We can write it as R is equals to E plus mole R plus H naught. You can write E to be equals to R minus H naught. R minus R is radial clearance minus H naught is equals to E. If I divide this E is known as eccentricity. So guys, this is one formula which is asked in engineering services many times. The second term is eccentricity ratio. When we are talking about the eccentricity ratio, guys, it is defined as E divided by C1. It is given by epsilon. And when you will be writing this, guys, it will be nothing but 1 minus H naught by C1. And it can also be written as 1 minus 2 H naught by C. This is the eccentricity ratio, guys. Hope you are getting it. Sir, please give brief difference between hydrostatic and hydrodynamic bearing. Dear, okay, I am giving you the differences in brief, but I am telling you with the table only. Sarath, in hydrodynamic there is provision for external lubrication. Dear, lubrication, when we are talking about, if you are going to give the external one, then it will become mixed lubrication, because external lubrication is provided in hydrostatic. C1 is radial clearance, C is diametral clearance. We have seen in the starting, C1 is radial clearance, and C is diametral clearance. Okay? Yes. So C1 and C you know. So C is 2 times C1. Okay? That's why we have written like this. C is 2 times C1. Okay guys. So this is something related to this. Is it fine, guys? Shall we move further now? Dear, just refresh it. It is not blur. Just refresh it or increase the quality from YouTube. Okay. So let us move further, guys. So don't worry, Prateek. In the last, I will be helping you in the difference hydrostatic and hydrodynamic. It is not very important. So we will see it in the end. No, dear, it is not that much high. It is very less. It is in microns. Okay, but I am showing that much just to make you understand. It is in microns. It is very, very less. Okay. Okay, dear. Great. So now we are talking about the next thing is bearing characteristic number. Bearing characteristic number is defined as Zn by P. When we are talking about Z, it is the viscosity of lubricant. N is speed in RPS. P is W by LD. W is the applied load. L is the length of bearing. D is the diameter. So dear, this LD is nothing but the projected area. You have already seen how these things are coming. Okay? Yes. Hi Prashant. Yes Akhilesh, you must remember this formula as it is asked many times in engineering services. So it can be asked in GATE also. So guys, next is Sommerfeld number. Sommerfeld number is given as Zn by P and into D by C ka square, or it can also be written as Zn by P or R by C1 ka whole square. If you are taking diameter, take diameter clearance. If you are taking radius, take radial clearance. This is the Sommerfeld number. So guys, Sommerfeld number has a significance that when you are having 1 mark का बहुत सिंपल क्वेश्चन आता है उस फॉर्मूले पर फॉर्मूला yes बिल्कुल सही प्रतीक, very good. Okay Sarath, so I would like to say guys, when we are talking about Sommerfeld number, if let us say you are saying 2 bearings are identical, if you are saying 4 bearings are identical, if you are saying 10 bearings are identical, then the thing is all the identical bearings have same Sommerfeld number. So dear, for identical bearings, Sommerfeld number are same. For identical bearings, Sommerfeld number are same. Okay, that is the thing I would like to tell you guys. Okay, so if you are going to have 2 identical bearing, you can equate the Sommerfeld number for them, and whatever one thing is given, not given to you, you can find out using S1 barabar equals to S2. Hope you are getting it. For identical bearing, Sommerfeld numbers are always equal. It is like a property. Okay. Okay guys, let us move further now. So dear, now we are going to see the last thing, that is power loss. Power loss expressions. For that I am coming on to one derivation guys. Let us see the power loss expressions. So guys, let us say we are having a bearing surface like this, which is a fixed one. We are having a journal like this. In between there is a lubricant. And guys, this very small thickness is H naught. This is the minimum oil film thickness. It is the minimum oil film thickness. Okay guys, dear, I already told you, Bhagwan Shankara, I already told you Sommerfeld number. Dear, there is no unit for that. Okay, have you seen the unit for Nusselt number? These are the numbers which are having some physical significance. I already told you that Sommerfeld number for 2 identical bearings are same. That is the physical significance of Sommerfeld number. And the significance of bearing characteristic number, I am just telling you after this concept. So dear, if you want to see this region only in a zoomed manner, you will be having one plate to be fixed like this. You will be assuming this to be a flat plate, which is fixed one, and shaft will be considered as a moving plate. and it is moving with some velocity which is equal to pi dn. And velocity profile is assumed to be linear, and you can feel that the in between gap is h naught. So this is just a zoom view for this part. So we are assuming shaft to be moving, bearing to be fixed. This is how we are assuming the things. Okay, this is how we are assuming the things. So guys, if you are assuming it in this way, I would like to tell you, when you are going to write the expression for shear stress, it is coming out to be, you are writing it, when you are writing in fluid mechanics, you are writing it mu u by v, mu u by y, or you can write it mu du by dy. This is the Newton's law of viscosity. So guys, if you are going to use this expression, in terms of mu you will be having z to be viscosity. In terms of du you are having velocity to be v. dy the distance is h naught. So dear, these are the expressions for shear stress coming. Okay, and if you want to write down the shear force, Pratik, my question is parameter unit used. Dear, that I already mentioned. Pressure will be Newton per meter square. Pressure will be Newton per meter square. Viscosity will be in Pascal. Okay, everything will be in SI units. Don't worry about that. Okay, everything will be in SI units. Small n will be RPS, revolution per second. I already mentioned that. If you have not seen, I already told you that. This n is the speed in RPS. Just see there. Okay guys, so Z is viscosity. Everything is in SI unit. Everything is in SI unit. Pressure is in Newton per meter square or Pascal. Okay. R1 and R and C1 will be having same units. They will be getting cancelled out. Okay. So dear, if you see this, we have written the expression for shear stresses. Now if you are going to write the expression for shear force, they will be coming out to be tau into area. Now you know that area of the shaft which is coming in contact is pi d into L, because bearing length is L. So you will be writing here, dear, shear force will be shear stress into area, which is equals to ZV by H naught into area is pi dl. You can also write it as Z into pi dn into pi dl divided by H naught. This is force. If you are going to write down the torque, it is going to be force into radius. It is Z into pi dn into pi dl divided by H naught. R can be written as d by 2. And guys, power is said to be frictional torque into omega. So these are the expressions for fixed power loss. These are the expressions for frictional torque. These are the expressions for shear force. These are the expressions for shear stress. And these are the expressions for velocity. So guys, these are the expressions from which one numerical may come. So dear, numericals are coming from this topic. It is very, very important topic. So guys, with this we have completed the second type of bearing also. And we are left with one more type, that is the ball bearing. Before coming on to that, let us solve 1 to 2 questions. And let us see the physical significance of bearing characteristic number also. Let us move further guys. Let us move further. Solve this question. For two identical bearing, this is the question. A natural feed journal bearing of diameter 50 mm, length 50 mm, operating at 20 RPS, carries a load of 2000 Newton. The lubricant has a viscosity of 20 millipascal Pascal second. The radial clearance is 50 microns. Find out the Sommerfeld number of the bearing. Sommerfeld number is Zn by P R by C1 का whole square. Yes guys, Try to solve this question, then we will move further, guys. Try to solve this question. Yes, guys. So first of all, put the values. First of all, find out P. Pressure is W by LD, and W is 2000. LD is 50 into 50. Dear, as the clearance is very small, in general, in this kind of formula, we take D and D to be nearly equal. And when you will be putting this, you will be getting 0.8 Newton per mm square or 0.8 Newton per meter square, but for that it is, okay, per mm square it is 0.8 MPa, and 0.8 MPa can also be written as 0.8 into 10 power 6 Pascal. This will be the value. Yes, Aman, hello. Dear, D is nothing but the diameter, and is nothing but speed in revolution per second. Speed in revolution per second. Everything I have just told, I feel you came late. Very good, Pratik, it is very much correct. Dear, everything you need to take in the SI units. So whatever is given, if it is given in millipascal, you need to multiply it by 10 power minus 3, that I have already done. So you just convert every unit to be the SI units. Yes, Naveen, it is given like that, so it is given wrong. But obviously don't worry, it is in SI, you will be using the correct unit. This is a misprint, okay? This is Newton second per meter square, what you are saying. But it is a misprint, so don't worry about that. You can use the right units. But yes, as it is millipascal, you will be multiplying it with 10 power minus 3. So the answer will be coming out to be 0.125. Abhishek Giri, yes, it is coming out to be 0.125. Very good, Vikas. All of you wonderful guys. So you guys have done it, guys, in a wonderful manner. Now let us complete this topic with the characteristic of bearing characteristic number. We have seen these expressions already. These expressions we have already seen. Yes, whatever the slides I have skipped, they are from engineering services conventional part. They are not for gate part. Okay. So now we are talking about the significance of bearing characteristic number. So guys, this is also known as Mackey's investigation curve. It is also known as Mackey's investigation curve. So when we are talking about the Mackey's investigation curve, if this is basically the curve for sliding contact bearing, and this curve shows that this is basically the mu is nothing but coefficient of friction. If you want to write down the formula for power loss, it can also be written as mu WB. And if you want to see about mu was defined by Petrov, given by Petrov equation, which says it is 2 pi square Zn by T into R by C1. This is known as the coefficient of friction. Putting this value here, you can find out the power loss. So dear, this equation is known as Petrov equation. Okay, so whatever we have done, that is also correct. This is another way to find out the power loss. So guys, if this is the curve which is coming from the experiments, and this is known as Mackey's investigation curve. Mackey's investigation curve, I am writing the spelling. It is Mackey's investigation curve. Okay guys, and for this curve, this is coming in this way, and you can see coefficient of friction is minimum for this value of bearing characteristic number. This curve is telling you about the physical significance of bearing characteristic number. So guys, for this value of Zn by P, this is the minimum value of coefficient of friction. So this value is known as alpha. This is known as bearing modulus. This is known as bearing modulus. This is known as bearing modulus. So bearing modulus is that value of bearing characteristic number for which coefficient of friction is minimum. For which coefficient of friction is minimum. For which coefficient of friction is minimum. Yes guys. So if that is the case, this is the mu minimum. So obviously if I ask you what should be the operating value of bearing characteristic number for you guys will be saying, sir, we must operate on this value of bearing characteristic number. It is known as bearing modulus because for this one coefficient of friction will be minimum. So you guys will be saying this should be the operating value because here the coefficient of friction is minimum. You can see coefficient of friction first reduces and then increases. Yes guys. This is how the coefficient of friction is varying. I will say in terms of lubrication, this part is known as thin film lubrication. This part is known as semi-thick film lubrication. Okay guys? And after that, this part is known as thick film lubrication. This part is known as thick film lubrication. So guys, this is the case. This is the case. This is how we are dividing the regions. So guys, first of all, if somebody asks you, you will say, sir, we want to operate it here. This region is said to be unstable, this is said to be stable. So guys, obviously, if you are thinking to operate at this, your thinking is very much correct. But guys, if you are going to operate at this, what can happen? I am telling you. Let us say you are operating at mu minimum. Let us say because of any reason, W is going to increase. If the W is going to increase, you know power loss can also be written as mu WV. So as W is increasing, power loss will increase. If power loss will increase, heat generation will increase. Power will be going to heat generation of heat. Heat generation increase will increase the temperature. And guys, once the temperature will be increasing, you know the viscosity of the lubricant will reduce. And once viscosity will reduce, your Zn by P bearing characteristic number will also reduce. And once it reduces, you will be coming towards left hand side. And here as you will be coming towards left hand side, obviously guys, your coefficient of friction will increase. Your coefficient of friction will increase. And once again, you know, as the coefficient of friction is increased, mu is increased, power will increase. Power will increase, heat generation will increase, temperature will increase, viscosity will reduce, Zn by P will reduce, you will again shift to right, left one, and once again moving to this value. And in that way guys, once again mu is increasing, the cycle will be repeating itself, and ultimately the bearing is going to fracture, it is going to the maximum value of friction, and it is going to fracture, it is going to fail. So guys, bearing will die automatically. You will just be looking at this, and guys, after looking at it, you will be having the failure of bearing, and this is the reason why it is said to be the unstable region. And guys, when we are operating in the stable region, this kind of thing will not occur. If you are acting in stable region, dear, in that case, obviously if you are going for this, let us you are operating at stable region, you are operating at some mu. Obviously at this, if W is increasing, obviously power loss will increase because of mu WV. And as it will be increasing, obviously power loss increase will be increasing the heat generation. Heat generation increase will increase the temperature, will reduce the viscosity. But guys, as viscosity will reduce, the bearing characteristic number will reduce, you will be coming here and mu is decreasing. So as the mu is decreasing, the cycle will not repeat, and guys, that's why this region is said to be stable region, this is said to be unstable region. Thanks to all of you guys for your wonderful messages, your wonderful comments. It is definitely a very good feeling when all of you are getting the things, I feel it to be wonderful. Guys, I am not feeling well because of my cold and fever, but still I am teaching just because of your way where how you are basically appreciating. That is the thing which is motivating me to take the class. Okay. Otherwise, the complete machine design I have taken in cold and fever for you guys. I didn't cancel the class because I know it is very crucial. Exam is very near for you guys. Thanks guys for your wonderful comments once again. So guys, I will say this is the curve, and that's why it is stable region. It is unstable region. And stable region is coming in thick film lubrication, which is either hydrostatic or hydrodynamic. Hope you guys are getting this curve, and that is the significance of bearing characteristic number. Now guys, with this we have completed the second type of bearing. We are moving to the last type of bearing, guys. Sorry for this extension. This class is going somehow bigger, but definitely we are going to complete the topic at least. So guys, now you tell me, can we have one more class where we can discuss about the brakes, about the spring, about the clutches, and about the cams and governors? So will it be okay if I take one class for all these topics? If you guys are okay with that, we can definitely have one class for that. Okay guys, let us move further. So, but we will be completing bearing by today only. We will be completing bearing by today only. Dear, the last type of bearing is rolling contact bearing. When we are talking about the rolling contact bearing, guys. Okay guys, wonderful. Sure we will be having that. Class. But I am planning that class on Saturday or Sunday so that the complete schedule of qualifier series shall not be affected, because complete schedule is already made. So I would take one class either on Saturday or Sunday so that the schedule of qualifier series shall not be affected. That is one thing I want to tell you. Are you okay with that, guys? Hope you are okay with that. Fine. So guys, now we are talking about the rolling contact bearings. So when we are talking about the rolling contact bearings, guys, the same curve which we are going between coefficient of friction and the number of revolutions, RPS. Dear, for sliding contact bearing, Mackey's investigation curve you have just seen. This curve will be coming for rolling contact bearings. This curve will be coming for ball bearings. If you see initially up to this point, this is the curve for ball bearing. The coefficient of friction is minimum up to this. And after this, up to this point, the coefficient of friction is minimum for roller bearing. And after this, coefficient of friction is minimum for sliding contact bearing. So guys, at slow speeds, ball bearings are preferred. At medium speed, roller bearings are preferred. At high speed, sliding contact bearings are preferred. So guys, that's why ball bearings are said to be the anti-friction bearing. The name itself is a misnomer. When we say anti-friction bearing, students have a misconception in their mind. They feel friction is absent. So guys, no, friction is not absent. Friction is present. But guys, the friction which is present, that friction is very less. So they are said to be anti-friction bearing. Hope you guys are getting it. And if you want to see the deep groove ball bearing, I am showing you that. Deep groove ball bearings seems to be like this. This is known as outer race. This is inner race. This is basically ball. And these are cage or separator. Cage or separators are used to have the balls equidistant to each other. So to have the balls equidistant to each other, to have the balls equidistant to each other, guys, to have the balls equidistant to each other, we are using cage or separator. And guys, these are the balls, you can see, and inner race and outer race balls are there in between. And when we are talking about inner race and outer race, out of these two only one race will rotate, other race will be fixed. Obviously, Naveen, I will be sharing that. So guys, out of these two races, one will be rotating, other will be fixed. And if you want to know the application, if you see the automobiles, in automobile axle is stationary, wheels are rotating. So if you will be using this kind of bearing in automobiles, outer race will rotate. But if in power plant shaft we are going to use it, bearings are stationary, shaft is moving, so inner race will rotate. So depending on application, one race will be rotating, other race will be fixed, guys. So when we are talking about this kind of bearing, the bearing number for this kind of bearing is known as 6. And guys, it is denoted like 6104. What is the meaning of that? 6 is the bearing number, 100 is the series, and this last two digit tells you the size of the bearing. I am telling you how. If you talk about the series, they are available in 5 series: 100, 200, 300, 400, 500. They are known as preferred series. When you are moving from 100 to 500, when you are moving from 100 to 500, guys, the size will increase, the cost will increase, load carrying capacity will increase. All of them will increase. So guys, if you want to see the difference between the series, I am showing you here. If this is a shaft, I am going to make a bearing like this. This is the bearing. Okay guys, if this is the bearing, this is the bearing, guys, and let us say I am making one more bearing. By looking at the size, you can say the second bearing is bigger than the first one. So if this is related to 300 series, this will be related to 400 series. Obviously, outer size will increase, inner cannot change because shaft is same. So outer size will change, ball size will change, inner size will remain the same. Okay guys, so this is how the things are defined. Now I am showing you about the sizes. So I am showing you about this. So dear, when you are having the number to be 6104, then this is bearing number 100 is the series. This last two digit you need to multiply with 5 and you will be getting the diameter. But some students have doubt. Okay sir, it is correct. Then for 6103 the diameter will be 15. No. This is valid after 6104. Because before that, if you are using 6100, its diameter will not be 0. It will be having a diameter of 10 mm. For 6101, 12 mm. For 6102, 15 mm. For 6103, 17 mm. After 6.04, you will use this formula. The Indian standard is denoted as IS 40 BC03. So IS for Indian standard, 40 is the size, BC is for deep groove ball bearing, and the 03 is the preferred series, like 300. Okay. So these are the two kinds of notation I have shown. That is international notation, that is Indian standards. Hope you guys are getting it in a wonderful manner. So let us move further, guys. Let us move further. One more thing I would like to tell you guys. When we are talking about this, these balls are always equidistant to each other. These balls are always equidistant to each other. So these balls are always equidistant to each other, guys. Okay? If you are going to change the position of balls, its load carrying capacity will be affected. So load carrying capacity is a direct function. Load carrying capacity is a direct function of the position of the balls. As the position of ball will change, obviously guys, as the ball's position will change, its load carrying capacity will also be changing. Dear Deepak Kumar, it is inner diameter. How it can be outer diameter? Because you already know outer diameter is changing with the series number. So it is the inner diameter we are talking about. Okay. Let us see guys further. So now we are talking about some important formula which we are going to discuss. Okay. Let us see what are the formulas. So guys, first of all, I would like to tell you the life of bearing. Okay, before that let us discuss the equivalent load. Equivalent radial load. Equivalent radial load. Now I am coming to the very important formulas which are going to be used in this chapter, from which the question will be asked. I already told you guys these are the radial load bearing. They perform well when the type of load is radial load. But guys, they can also bear some small amount of axial load also. So if you are going to find out an equivalent load, means there are when let us say there are two springs which are joined either in series or parallel, you will be making them an equivalent spring. Similarly, when there are two things are joining, you are going to find out the equivalent of them. You need to have that single value which can have the work equal to those two or three things. Similarly guys, when it comes to equivalent radial load, it is that alone load which can compensate both radial and axial load which are in real applied load. So guys, this PE can be written as X times FR into V plus Y times of FA into S. So guys, when you are talking about this formula, here X is known as radial load factor. X is known as radial load factor. X is known as radial load factor. So guys, X is always found to be lesser than 1 because these bearings are very good in radial load. So radial load factor is lesser. When we are talking about FR is the radial load value. FR is the radial load value. Then V is known as the race rotation factor. V is the race rotation factor. Y is known as axial load factor. And guys, FA is the axial load. And S is known as the service factor. All this value will be given to you guys. And race rotation factor is said to be 1 if inner race rotates. It is given to be 1.2 if outer race rotates. So dear, in this way we are having the discussion of this. So hope you guys are getting in a wonderful manner. So this is the equivalent radial load. It is said to be equivalent radial load. Okay? Yes. So guys, this is the very first term we have discussed. Now guys, this is the formula. Now we are coming to the bearing life. Now we are coming to the bearing life. Dear, now I would like to tell you what is bearing life. In case of bearing life, we are going to use a wonderful concept of reliability. Guys, bearing life is defined as the rated life. First of all, what is the meaning of life? Dear, life will be the number of million revolutions or the number of hours before fracture. This is in general the definition is. But guys, I am coming on to one very important point, that is the reliability kind of thing. What is that reliability? Dear, if I tell you one thing that when it comes to bearing life, when we are talking about bearing life, if you are talking about one thing, and that one thing is that we are having 100 bearings. 100 bearings, we are having the equal loads and they are rotating at the same revolution. Then what I found is, after some time 10 bearings got failed and I left with the 90 number of bearings. 10 bearings got failed, I left with the 90 bearings. So dear, the number of revolutions we have covered with the 90 bearings safe, then that number of revolution is known as bearing life. So guys, bearing life is defined as the rated life. It is that life which is going to be there for which the 90% of the bearing will exceed. That is said to be the bearing life. So guys, this bearing life is defined as L90, that is for which 90% bearing are safe, or L10 for which 10% bearing are fail, and it is given in million revolution. But let us say if this life is given in terms of number of hours, then how to convert it into the million revolution? How to convert it into the million revolution? Then guys, you will be writing L in million revolution is number of hours into 60. It converted in minutes into RPM converted in revolution. Divide by 10 power 6 will give you million revolution. So this is the formula used to convert the life in hours into the life in million revolution. This is something known as bearing life, guys. It is something known as bearing life. Okay guys, hope you guys are getting the things in a wonderful manner. This is something known as bearing life. So guys, after this bearing life, we have already discussed one type of loading. There is second thing known as cubic mean load. There is something known as cubic mean load. Dear, if I am saying cubic mean load, what is cubic mean load? Guys, let us say the load is changing. Load is changing. I am saying that for first T1 time, load is different. For second T2 time, load is different. And then for T3 time, load is different. So dear, for first T1 time, let us say this is the value of radial load FR1. Let us say this is the axial load FA1. So with the help of this, you can find out the equivalent load 1. For the second cycle, let us say this is the radial load 2. Let us say this is the axial load 2. From this, you can find out the equivalent load 2. For the third, let us say this is the radial load 3. Let us say this is the axial load 3. You can find out, guys, the equivalent load 3. So you can find PE1, PE2, PE3. Let us say N1 RPM is speed here, N2 RPM is speed here, N3 RPM is speed here. So RPM into second, you will be getting small N1 revolutions. RPM into time, you will be getting some revolution. N2. N3 into T3, you will get some revolution. Okay guys. So guys, this is the PE1 equivalent radial load in first cycle, equivalent radial load in second cycle, equivalent radial load in third cycle. If this kind of variations are coming, then what you will be taking an equivalent radial load. Then equivalent radial load is given as cubic mean. It is cube root of, it will be coming out to be, guys, PE1 1 by 3. Sorry, it is going to be cube because it is inside the cubic cube root. It is PE1 cube into N1 plus N2 into PE2 cube plus N3 into PE3 cube divided by N1 plus N2 plus N3. This is how you will be finding out. This is the formula from which question have never been asked, but it will be coming in any year. We are waiting for the year to come when it will be asked. Okay guys, hope you guys are getting it in a wonderful manner. Please tell me you got it or not so that we can move further. So guys, we have seen the cubic mean load. Now we are coming on to the load carrying capacity and then we are going to load life relationship. Only 3 formulas are left. Okay. Yes. Hope you guys are getting it. Let us see guys the next thing is load carrying capacity. Load carrying capacity. So when we are talking about the load carrying capacity, guys, load carrying capacity, there are 2 types, but we need to study only dynamic one. We need not to go for static load carrying capacity. Dynamic load carrying capacity is also known as catalog rating. It is also known as catalog rating. It is also known as catalog rating. So guys, this is defined and denoted by C. It is that value of equivalent radial load. It is that value of equivalent radial load for which L90 is 1 million revolution. So guys, this is that value of equivalent radial load for which the rated life will be 1 million revolution. Rated life will be 1 million revolution. So this is known as dynamic load carrying capacity. So it is simply the load for which the life will be. load for which the life will be, rated life will be 1 million revolution. I will say 1 million revolution. Okay guys, so when we are talking about this, there is a formula from which 100% question are asked till date. Mind my words, I said 100% question from the ball bearings are been asked only with one formula, that is load life relationship. Load life relationship. It is C by P, L to the power 1 by K. This is the formula which is known as load life relationship, and all the questions till this date from this chapter are being asked from this formula only. And here K is given as 3-4 ball bearing. And then K is said to be 10 by 3 for roller bearing. Okay guys, so this is the load life relationship. Guys, majority, all the questions are coming from this formula only. That's why it becomes more and more important for us. Now I am coming to the last formula. From that also there is no question asked till date. That is the relation between any life divided by rated life. So any life, maybe let us say you want to write the relation between L60. So it will be coming out to be Ln 1 upon R. R is the reliability. Okay, let us say we are finding out any life divided by Ln 1 upon reliability 90 to the power 1 by 1.17. Let us say you want to write the relation between L50 and L90. You will be writing Ln 1 by 50 and divided by Ln 1 by 90. Okay, you can take 0.5 or 0.9 also. You will be getting the same. To the power 1 divided by 1.17. And here from this you will be getting L90 to be L50 to be. From there you will be getting L50 to be 5 times the L90. This L50 is known as average life. This L90 is known as, yes, nominal life or rated life. So guys, with this we have completed this chapter. We are concluding this session with one question. Dear, L90 and L10 are same. Dear, L90 or L10 same. 90% bearing pass or 10% fail. L80 or L20 same. L70 or L30 is same. L60 or L40 is same. 90% pass or 10% fail. 80% pass or 20% fail. 70% pass or 30% fail. 60% pass or 40% fail. 50% pass or 50% fail. After that, it is not defined. Yes, Akhilesh Khadse, I am telling you one thing, that if you see the previous formula, it will be C divided by P equals to L90 to the power 1 by K. Okay, K is a constant. This is one question. With this question, we are concluding the session. The last question. With this, we will be completing this session, guys. So this question is the expected life of a ball bearing subjected to a load of 9800 Newton. So PE1 is nothing but 9800 Newtons and working at 1000 RPM. 1000 RPM is 3000 hours. So life in hours is 3000. What is the expected life of the same bearing for a similar load of 4900 Newtons at a speed of 2000 RPM? Okay guys, and LH2 you need to find out. So guys, first of all, this formula, this is life in million revolution. This is not the life in hours, so you need to convert it. And this is dynamic load carrying capacity. This is same for identical bearings. C is same for identical bearing. So it can also be written as P1 L1, that is obviously L1 90 to the power 1 by K is equals to P2 L2 90 to be for 1 by K. Because C is same for two identical bearings. And you can also write it P1 is nothing but 9800 Newton. L1 90 can be written as the life of hours 1 into 60 into revolution 1 divided by 10 to the power 6. And you can write it to be equals to 4900 into to the power 1 by K will come. It is LH2 into 60 into N2 divided by 10 power 6. Guys, everything is given. You need to find out LH2. Find out LH2 with this formula. And always mind the power is 1 by K. In this question it is ball bearing. Take K to be equals to 3 and solve it now. This is a wonderful question. Dear, static load carrying capacity will not be given to you because for static load carrying capacity there is no numericals. Why? Because static load carrying capacity is for the condition when the shaft is not rotating. So dear, if shaft is not rotating, there is no need of bearing, then it will become axial. So dear, it is very much simple to say that static load carrying capacity is related to the stationary condition. So it can be asked in interviews, but it cannot be given in numericals. For numericals, you always have to see the dynamic load carrying capacity. And in the university exam, when they were giving static, you were using the data book to find out the dynamic with the help of static. So in GATE, you will not be getting that kind of question. Static load carrying capacity, if given, it will be redundant data only. Okay. So they will be giving you dynamic load carrying capacity always. Solve it guys. I want answer from you guys. Very good. Bhagwan Shankara. The answer is 12,000 hours. Okay, fine. So guys, with this we have completed the bearing chapter. Now I will be taking one session for the pending topics. I will be announcing the date for that on the Telegram channel. Guys, I will be sharing this PDF after the class into your group. So guys, those who want to attend the deflection of beams, it is about to come on Tuesday. Not on Tuesday, but yes, on Tuesday on the Mechanical Marvels channel. You can attend it there. Deflection of beams, I will be taking there. It is going to be very, very important session, and that will be coming in GATE exam for 2 marks. So you guys can join there for deflection of beams. Okay. So guys, thanks for your love and support once again, and thanks for joining. We will meet soon for the pending topics. Goodbye guys for this session. Once again, thanks to you. Okay, thanks dear for your wonderful words. Dear, I am taking strength of material, a part of production, machine design on the new channel. Okay, that is Gradeup GATE mechanical channel. Here I have already completed strength of theory of machines, vibration. Those topics are already completed for you guys. Okay, you welcome Vikas. CB Gautam, okay, you welcome dear. Thanks Deepak. Okay, Venkatesh, you're welcome. Goodbye guys. Goodbye.